The 9 biggest industrial machines ever built by mankind. Must see. At some point in history, humanity stopped asking, can we build it? And started asking something far more dangerous. How big can this become before the world has to change around it? These aren't machines made for convenience. They weren't designed to be elegant or even efficient by normal standards. They exist because entire industries demanded scale. Scale so extreme, landscapes were reshaped, infrastructure was rewritten, and engineering limits were pushed to their breaking point. Today, we're counting down the 9 biggest industrial machines ever built by mankind. Machines so massive, trucks disappear beside them. So powerful, they don't adapt to the world adapts to them. And the machine at number 1? It didn't just move the earth, it redefined what too big even means. Ranked 9th. Belaz 75710, the truck that redefined too big to move. For most of industrial history, mining trucks followed a simple rule. Make them bigger, but not too big. The Belaz 75710 is what happens when that rule is deliberately broken. Built in Belarus, this machine wasn't designed to impress crowds or set internet records. It was built for one brutal purpose: to move more earth in fewer trips than anything that came before it. At first glance, it looks like a familiar haul truck, just oversized. But the numbers tell a very different story. The Belaz 75710 can carry up to 450 metric tons in a single load. That's more than some naval vessels displace when fully equipped. To handle that weight, engineers abandoned traditional layouts and gave it 8 massive tires, each standing taller than a grown adult. Power doesn't come from brute force alone. This truck uses a dual-engine diesel-electric system, feeding electricity to individual wheel motors. The result is controlled movement under extreme load. Not speed, not elegance, but relentless stability. When the Belaz 75710 enters an open-pit mine, operations change around it. Loading schedules shift, haul routes are reinforced. Even maintenance planning adapts to the reality that this machine doesn't fit into existing assumptions. And that's what makes it remarkable. The Belaz 75710 isn't the largest machine ever built, but it represents the upper edge of what mobility still allows. A machine so large, the industry had to ask a new question. Not how much can we move, but how much is it still practical to move at all? Ranked 8th, Bucyrus R. H400. When digging became an industrial operation. Before trucks like the Belaz 75710 can move the earth, someone has to lift it out of the ground. That job belongs to machines like the Bucyrus RH400, the largest hydraulic excavator ever built. At first glance, it doesn't look dramatic. No rotating wheels, no towering conveyors, just a massive arm, a bucket, and an unshakable presence. But this machine changed how modern open-pit mining works. The RH400 was designed to load ultra-class haul trucks efficiently, not once, not twice, but thousands of times without pause. Its bucket alone can move more than 100 tons of material in a single pass, turning what used to be hours of work into minutes. Hydraulics are the key. Unlike cable-driven machines of the past, the RH400 uses precision-controlled hydraulic systems that deliver power exactly when and where it's needed. That precision allows for smoother cycles, reduced wear, and continuous operation under extreme stress. Standing next to it, scale becomes difficult to process. The operator sits meters above the ground. Service platforms resemble balconies. Even nearby haul trucks appear reduced, not by size but by comparison. When the RH400 enters a mine, the entire workflow reorganizes around it. Truck fleets are selected to match its output. Bench heights are redesigned. Production targets are recalculated. The Bucyrus RH400 doesn't chase records. It enforces efficiency. And in industrial engineering, that may be the most powerful kind of size there is. Ranked 7th. Big Muskie, the machine that was too big for its own time. Long before modern mines were optimized by computers and logistics software, there was a machine so large, it didn't just work the land, it reshaped it permanently. This was Big Muskie. Built in the 1960s in Ohio, Big Muskie remains the largest dragline excavator ever constructed. Not the tallest, not the longest, but the heaviest land-based machine of its era, a mechanical giant designed to remove entire layers of earth in a single motion. Unlike hydraulic excavators, Big Muskie didn't rely on precision. It relied on sheer mass. Its bucket alone weighed more than many modern excavators combined. When it moved, the ground beneath it flexed. When it dug, entire hillsides changed shape. And yet, for all its size, Big Muskie was surprisingly fragile in one way. It could not move freely. This machine didn't travel from site to site. It was built for one landscape, one job, one purpose. Strip mining on a scale that modern environmental standards would never allow today. Operating Big Muskie required its own ecosystem. Dedicated power supply, specialized crews, maintenance schedules planned around a machine that could not simply be replaced. Eventually, economics caught up with it. Newer machines became smaller, faster, and more efficient. Big Muskie was dismantled, not because it failed, but because the world around it changed. Today, parts of it sit in museums, not as scrap, but as evidence of a moment when industrial ambition asked a dangerous question. What happens when size becomes a solution to everything? Ranked 6th, Liebherr LR 13,000. When the world needed to lift the impossible. Digging the earth is one kind of challenge. Lifting the impossible is another. That's where the Liebherr LR 13,000 enters the story. This isn't a machine designed to move. It's a machine designed to hold the weight of the modern world in the air. The LR 13,000 is the largest crawler crane ever built, capable of lifting more than 3,000 metric tons in controlled, precise operations. Not in theory, not in simulations, but on real construction sites, assembling refineries, power plants, offshore platforms, and infrastructure too heavy for anything else to touch. Unlike older cranes that relied on brute force, the LR 13,000 represents a shift in philosophy. Modular design allows it to be transported in parts. Advanced control systems manage load distribution in real time. Every movement is calculated, not improvised. When fully assembled, its boom rises like a steel skyline. Standing beneath it, scale becomes disorienting. What looks static from a distance is actually under constant tension, balancing gravity, momentum, and material stress with almost surgical accuracy. But the true significance of the LR 13,000 isn't its lifting record. It's what happens because it exists. Projects once considered impossible are now planned as routine. Structures once built in pieces are lifted whole. Construction timelines shrink, not because the work is easier, but because the limits have moved. The Liebherr LR 13,000 doesn't dominate landscapes like mining machines do. It appears, lifts what no one else can, and disappears, leaving behind structures that redefine scale long after it's gone. Ranked 5th, NASA Crawler Transporter. The heaviest machine that ever learned to move. Most of the machines on this list reshaped the Earth. This one was built to carry the future. The NASA Crawler Transporter doesn't dig. It doesn't lift. It doesn't haul materials across mines. Instead, it moves something far more delicate: entire space launch systems. Originally built in the 1960s for the Apollo program, the crawler remains the heaviest self-powered land vehicle ever constructed. Fully loaded, it weighs over 6,000 metric tons, more than many warships. Yet it moves at a pace slower than walking speed. And that slowness is intentional. Every inch of movement must remain stable. A slight vibration could compromise a rocket. A minor imbalance could delay a mission measured in years. The crawler rides on 8 massive tracks, each one engineered to distribute weight evenly across a specially reinforced roadway. Power comes from diesel engines driving electric motors, not for speed but for control. Standing beside it, the scale feels almost deceptive. It looks calm, unhurried, but every system on board is working to keep thousands of tons balanced within razor-thin tolerances. What makes the crawler remarkable isn't just its size, it's its longevity. Decades after its creation, the same machines still transport modern launch vehicles for NASA's newest programs. Upgraded, reinforced, adapted, but never replaced. In a world obsessed with faster and newer, The NASA crawler transporter proves something different. Sometimes the greatest industrial achievement is building a machine so well it never needs to be reinvented. Ranked fourth, Takraf SRS 8000, when size had to become efficient again. After machines like Big Muskie proved how far brute force could go, industrial engineering faced a problem. Bigger alone was no longer enough. That's where the Takraf SRS 8000 comes in. This is a modern bucket wheel excavator built not just to be massive, but to operate continuously, predictably, and at industrial scale. Day after day, year after year. Unlike older giants that relied on overwhelming weight, the SRS 8000 represents a new balance between size and system efficiency. Its rotating bucket wheel cuts steadily through overburden, feeding material onto an integrated conveyor network that never stops moving. There are no trucks waiting in line, no pauses for loading cycles, just a constant flow of earth, measured in thousands of tons per hour. What makes this machine remarkable isn't a single record-breaking number. It's the way it fits into a fully synchronized mining ecosystem. The SRS 8000 doesn't work alone. It's designed to operate alongside spreaders, conveyors, and power systems that stretch across entire mining fields. Once it starts, the operation becomes less like excavation and more like an industrial assembly line carved directly into the landscape. From a distance, the machine looks almost unreal. A moving structure, a factory on tracks, a reminder that in modern mining, scale isn't about domination anymore. It's about continuity. The Takraf SRS 8000 shows what happens when engineering stops chasing spectacle and starts optimizing size itself. Ranked third, F60 overburden conveyor bridge. The machine that broke the meaning of distance. Most machines on this list impress you by their height or their weight. The F60 does something different. It overwhelms you with length. Built in Germany for large-scale lignite mining, the F60 is the longest industrial machine ever constructed, stretching more than 500 meters from end to end. Longer than aircraft carriers, longer than most city blocks. And unlike ships or trains, this entire structure moves as a single machine. The F60 isn't designed to dig or lift. Its purpose is far more specific: to transport massive volumes of overburden continuously, without trucks, without stops. As material is excavated elsewhere, it flows onto conveyor belts that run the full length of the machine. What enters on one end is deposited hundreds of meters away on the other, creating a steady relocation of the landscape itself. From a distance, the F60 looks impossible to comprehend. Too long to fit in frame, too wide to grasp from the ground. Only aerial views reveal what it truly is: a moving bridge built not over water, but over earth. Engineering a machine like this required abandoning traditional thinking. Flexibility had to be designed into the structure. Movement had to be synchronized across hundreds of support points. Every meter had to remain aligned under constant load. The F60 proves something few machines ever do. At extreme scales, size stops being about power and becomes a problem of coordination. When distance itself becomes the obstacle, the F60 is the solution. Ranked second, Pioneering Spirit, the machine that lifted the ocean itself. Up to this point, every machine on this list has one thing in common: they operate on land. The Pioneering Spirit changes that completely. This is not just the largest construction vessel ever built. It is one of the largest machines humanity has ever assembled, period. Designed by all seas, the Pioneering Spirit was created to do something no other machine could manage reliably: lift entire offshore oil and gas platforms in a single operation. Not dismantle them, not cut them apart. Lift them whole. With twin hulls spanning more than 100 meters, the vessel straddles offshore structures like a moving dry dock. Its lifting systems apply force with millimeter precision, raising platform topsides weighing tens of thousands of tons straight out of the sea. There are no dramatic movements, no sudden shifts. Everything happens slowly, because at this scale, speed becomes risk. What makes the Pioneering Spirit extraordinary isn't just its size. It's the fact that it turned a complex, multi-month offshore operation into a single engineered moment. Entire industries adjusted around it. Decommissioning strategies changed. Project timelines collapsed from years to weeks. Costs and risks dropped dramatically. From above, the vessel looks unreal. Too wide, too symmetrical, too calm for the forces it controls. The pioneering spirit doesn't dominate the ocean, it works with it, quietly proving that industrial scale doesn't always need to be aggressive. Sometimes the biggest machines succeed by being precise enough to lift the sea without disturbing it. In first place, Bagger 293, the day scale lost all meaning. At some point, size stops being impressive and starts becoming difficult to understand. That's the moment you encounter Bagger 293. This is the largest land-based machine ever built by mankind. Not a symbol, not a prototype. A working industrial machine designed to move the Earth itself. Built in Germany for continuous mining operations, Bagger 293 weighs more than 14,000 metric tons and stands taller than a city building. Its rotating bucket wheel alone carries the power to remove entire layers of ground in a single uninterrupted motion. But the true scale of Bagger 293 isn't found in numbers. It's found in perspective. From ground level, the machine doesn't fit into view. From the air, it stretches beyond the frame. People standing beneath it don't look small, they vanish. Every system on Bagger 293 is built around one idea: continuous movement at impossible scale. Material flows from the bucket wheel onto conveyors, from conveyors to spreaders, from spreaders to landscapes that no longer resemble what existed before. There are no pauses, no dramatic moments, just relentless, controlled transformation. Operating Bagger 293 required more than engineering. It required rewriting infrastructure, power supply, terrain planning, logistics, all redesigned to serve a single machine. And that is why Bagger 293 stands alone. Not because it is the biggest, but because it represents the final question industrial engineering ever dared to ask. If size solves everything, what happens when we reach the point where nothing bigger is practical anymore? Bagger 293 is not just the largest machine on Earth. It is the moment humanity discovered that scale itself has a limit. When we look back at these machines, it's easy to be impressed by numbers. Tons, meters, megawatts. But what truly matters is what they represent. Each one exists because at some point, humanity believed that scale was the solution. That if a problem was big enough, only something even bigger could solve it. Some of these machines are still working today. Others belong to history. But all of them mark moments when engineering pushed right up against the edge of what was possible. And maybe that's the real legacy of the world's biggest machines. Not how large they were, but how clearly they showed us that even scale has limits. If you enjoyed this documentary, subscribe for more deep dives into the machines that built our world. And tell us in the comments, which machine truly felt impossible to you and why?